Welcome back again. It's time for our third example. This time we're going to apply union and intersection to a geometry diagram. So quickly I should just make a comment again that we know we can assume straight lines on a diagram. So we can assume that that is in fact a straight line. We can assume that is in fact a straight line. Sorry. Jumping into union and intersection, however, let's take a look and see if we can find, let's start with intersection. So let's find the intersection between line AC and line DE. So again, on these, I find it very useful to use color. So line AC looks like that. Line DE looks like that. And the question is asking me to find the intersection. So the intersection, remember, is the overlap. So the overlap between those two lines, pretty clear, they intersect at B. This time, let's take a look and see where segment AC, which is that, intersects with segment BC, which is that. So again, it is an intersection. Intersection says where do they overlap? They overlap right here. That's where the blue and the red overlap, and it has a starting point and an ending point. Therefore, it is segment BC. Now let's look at the intersection between two rays. So what if I want the intersection of ray AB, which goes that way, and ray BC, which goes in the same direction? Okay, where's the intersection? The intersection, where is the red and the blue overlap? Right there. So clearly it is a ray starting at B and passing through point C. This time, let's see what happens if I turn that second ray around. So first, we still have ray AB, which still looks like that. Secondly, now I have ray CB, which starts at C and goes this way. So now we're still looking for an intersection. So the intersection is the overlap. They overlap right here. So this time I have two rays intersecting and they form a segment. Okay, I want to look at one more intersection. What happens when segment AD is asked to find the intersection with segment EC, and they clearly do not intersect. There is no overlap. We need a way to say that. We need a way to show that or to have notation for that. So I have a choice. I can either use the no solution symbol. Okay, it's asking me to find the intersection. I'm saying, nope, there's no solution to the question you are asking me. Or I can use what's called the empty set. So remember the answers go into that set notation, into those braces, and if there's nothing in there, that implies that there is in fact no intersection. Okay, this time let's switch over to union. So let's find the union between segment AC, which is all of that, and then segment BC, which looks like that. So this time it is a union. A union, remember, takes everybody. So anything touching the red is part of the answer. Anything touching the blue is part of the answer. So therefore, my answer is segment AC. This time, I'm going to ask for the union of two different rays. So specifically, it's ray BE, which looks like that, and then ray BD, which looks like that. And maybe you heard while I said it, but I have two different rays. They both have the same endpoint, and because the two rays sit on the same line and go in opposite directions, these are opposite rays, and the union of these opposite rays form the line. I personally would call the line DE, but you have your choice. You can switch the order and call it line ED. Perhaps you want to call it DB. Okay, perhaps you want to call that line BD. And you even could say line BE or line EB. Your choice, any one of those six is perfectly acceptable. Let's look at what happens if I change that second ray from ray BD to ray BC. So now, seeing the two parts marked, I have ray BE, that's the same, and then I change to ray BC, which is down here. When I look at the union of those two rays, okay, the union of two rays with a common endpoint is by definition an angle. So I look at this and I see angle EBC. Okay, using our concept of what does it mean to be a union takes everybody. Looking at the red part, putting it together with the blue part, standing back and looking at it overall, I see the angle. Last one, hopefully you're still with me. So one more union, but this time I'm going to take the union of three segments. Okay, segment AB, which is here, segment BD, which is here, and then segment AD, which is here. The union takes everybody. So when I stand back and I look at those three labeled parts, what do you see? You should see the triangle. So we have triangle ABD. And again, order of the letters is irrelevant, so if you would rather call it triangle ADB, triangle BAD, triangle DAB, or so on and so on and so on.